Afternoon, colleagues. We'll start in it. Good afternoon, colleagues. Welcome to our session today. I am Karen Johnson, math coach. I'll be hosting this session, and we have several presenters with us. We're so grateful and happy to have you joining us today. Just doing a mic check though. Are you able to hear and see me?
Loud and clear, sir.
All right, thank you very much, Miss Townsend. We are just gonna go straight into our devotional exercise. And so I was tasked to do the devotion. So hopefully you are not being bothered too much by the rain outside. And we are experiencing some rain here in Mandeville at this time. All right, so I'm just going to share my screen briefly. All right, so internet is moving a little bit slowly. So I'm gonna start off with a song, Love, Wonderful Love. All right, so please join me in a word of prayer. Our Father in heaven, we are truly grateful for this time to be among our colleagues, to participate in this workshop. We are grateful and thankful for the technology that Thou has afforded us to do so. And we pray that by the Holy Spirit will be guided and we will be so influenced as whatever is said and discussed will enlighten us and help us to draw closer to Thee and help us to know and learn our responsibilities and to carry out our duties more effectively. We pray for these things in Jesus' name, amen. So I thought about this theme this morning, colleagues, and it's just going to be a very brief devotion. Love thyself. The scripture that I have is Matthew chapter 22, verses 39. So it is a well-known scripture when Jesus was asked, which is the greatest commandment in the law? And he said that the first, thou shalt love the Lord thy God with all thy heart and with all thy soul and with all thy mind. This is the first and great commandment. And the second is like unto it, thou shalt love thy neighbor as thyself. So, generally we ask, who is your neighbor? And, we are reminded that our family members could be our neighbors, our children, whoever is in our household could be our neighbors, persons that we meet. But I was thinking about it a little bit deeply. Our point of reference for our love. And the scripture says, love our neighbors as ourselves. And I thought about that, just how much time have we dedicated to love ourselves? Or is it something that we don't really consider? And so I wanted to just share a little bit on this for our devotion today. Because sometimes we may find it that we may find it easier to love other persons and to not give ourselves much love because we hold ourselves at so much of a high standard, and sometimes we find it hard to forgive ourselves. And so that is our basis, if we are if we want a point of reference as to how to love other persons, then we should start with ourselves, right? Because we should love our neighbors as ourselves. And so just for a few self-care advice. So in terms of physically, some of the ways we can show love to ourselves is by eating healthily, resting, exercise. For emotional, we can look at, manage our stress management, forgive ourselves. We are human beings, we make mistakes. But once we learn from it, right, we should not hold ourselves in such a way where we don't want to forgive ourselves, right? Forgiveness is healing to our souls as well. Being kind. For social, we're looking at boundaries. And as teachers, we definitely need to set our boundaries or even our peace of mind. So we think about that too. We need to have a support system, and whatever structure we have, maybe people around us, we need to have that support system for us. We need to ask for help when we really can't manage, and probably even before we reach to that state of, breakdown, we really need to see where we need to ask for help, and then we do so. Spiritual, time alone or alone time, we need that time to meditate. And of course, we need our sacred places. So as we work towards achieving, our best self, and we do so with God, because with God, all things are possible. That we think about loving ourselves and doing the action that, shows that. And I say these few words in Jesus' name, amen. So thank you again for coming out and making the sacrifice to be here. Just want to make special mention of Mrs. Janet Shaw Gooden, Education Officer, who is with us, and also our Regional Math Coordinator, who will now bring greetings, Mr. Lamar Ejil. Turn the time over to you now, Mr. Ejil.
Thank you so much, Mr. Johnson. Good afternoon, colleagues. It's really a good thing when we can meet together to engage in professional developments such as this one. I want to really welcome you all to our session that focuses on our Pathway 3 students. And we know for a fact that the pandemic, it came in and disrupted how we go about conducting our day-to-day lives, and also to extent, it has also impacted how we engage our students. And as we are now in the virtual space and trying our best to ensure that we meet our students, we need to spend some time to single out our students who are actually a part of Pathway 3. So we have decided today to call on our Pathway 3 teachers, our APSE teachers of Pathway 3 students, as well as our APSE coaches, so that we can look at what we can do to assist you in bolstering your effort towards engaging students from these pathway levels in the virtual space. Really hope that you'll stay for the full duration of the session. We hope that there's something from the session that you can take and apply to your practice. And we here at the ministry, the math team, continues to provide support to you in any way we can. So even beyond this session, where it is you see that you need further assistance and guidance, help, we are still here to support. And we pledge that support to you, or teachers who are really at the front line battling it in this time with COVID-19 really impacting how we go about looking at teaching and learning. So please enjoy the session. Please participate. Open the mics and speak when the time is right. Raise your hands, and also use the chat. Share your thoughts, because we want to hear from you. And as much as how we have prepared a session for you, we know that you too all have your own best practices, that if you mention some things that are related to what we're doing today in the chat, I'm sure others would benefit from what you're doing. We are a community of leaders. We're a community of teachers who engage students in various pathways. And I believe that you have common challenges, and with common challenges, you may also have diverse but shared solutions that others can be made aware of, so that going forward, we can just continue to show forth our best in service of our students. So today's theme is keeping students engaged as they overcome challenges and master concepts in mathematics. Quite a mouthful, but I'm sure that the wonderful team here will engage you well. You will hear from our cluster-based math specialist, Miss Michelle Townsend. You will hear from our secondary coaches, Dr. Isilda White and Mr. Karan Johnson. I leave you in their able hands. All the best, and over to the team. Have a wonderful session.
All right, thank you very much, Mr. Edgel. All right, so at this time, we're going to introduce our members who will be presenting today. So I'll go ahead. I'm Karan Johnson, secondary mathematics coach. I really and truly appreciate you making the time to be here this afternoon. And I, as Mr. Edgel said, that we just want you to be free in terms of communicating, participating, so that we all can learn and grow together. All right. And so without further ado, I'm going to start with our cluster-based mathematics specialist, Ms. Townsend, and then Dr. White. You can go ahead and introduce yourself, colleagues.
Okay, good afternoon, colleagues. It is so good to be here with you once more. And I do hope that you will not only enjoy the session, but I look forward to your full participation. Not hearing you, Dr. White.
You can go ahead.
Okay. Yes, good afternoon, everyone. Hearing me now?
Loud and clear, Dr. White.
Okay.
Go ahead.
Good afternoon and welcome, everyone. We are happy to have you. And as my team members have said, I'm sure you're going to enjoy the session, and we look forward to your full participation. Take care.
All right. Thank you so much, colleagues. So we are going to go just some house matters. Please, by now you should see in the chat registration link. We'd want you to just click on that so that you can mark yourself present at this session. Very important. So please follow the link and mark yourself present. Mrs. Shaw Gooden, Education Officer. I don't know if you have anything to say. It was not on the schedule, but we're just gonna see at this time if you would like to say anything to our participants here.
Just like Miss McDonald said, please.
Okay. Okay. Let me. Are you able to speak, Mrs. Shaw Gooden?
Yes, I am.
Yes.
I am in another meeting, so
Okay.
you understand. So I try to mute the device so that you won't have that feedback. So let me say good afternoon to all our participants, and special commendation to the mathematics team for the efforts made this afternoon. And we at the regional office, of course, endorse this activity, and we want that all persons must be involved, as Mr. Edgel would have mentioned. When the time comes for you to participate, do so, and pay keen attention to what will be shared with you today, because definitely every effort is really to make you better off. All right, so we look forward to the engagement and the benefits that will be derived, and how you will use this knowledge in your day-to-day deliveries in the classroom and support to our children. All right, so that's about it. All the very best, and continue to keep safe.
All right, thank you so much, Mrs. Shaw Gooden. All right. All right, so our presenters, so while our participants traverse the virtual space and register at this time, Ms. Townsend will be our first presenter. So I'll now invite Ms. Townsend to start the presentation. Thank you.
Okay, thank you so much, Mr. Johnson. Okay, so, one of the things, as we said, is we talk about you guys talking to us. And we want to ask, I'm really putting this out there for you to hear from you. You can type in the chat, who would you prefer to teach? So, you're looking at the pictures there on screen, and I want you to share with me, who would you prefer to teach? So I want you to type that name in the chat. And I mean, if you want to even add a little reason, not a problem. But I want to hear from you. And I'm seeing one person in the chat already saying no preference. Okay, Kevin Grant says no preference. Okay, I'm seeing Clan. All right. I see Jen. Okay, and I see Clan repeated. So I'm seeing a variety of, well, I've seen variation. That's it. Mr. Neil said everybody, and I'm liking that. So I'm wondering now, and I know that I have quite a few persons, so I take it that probably some persons are still thinking. All right, so I noticed that McCade and Morris would have put a reason. Clan seems like he is thinking. And I see other persons putting all and Jen. So I just want just one person. I don't know if Miss Wallace or so would like to share their reasoning behind the name that they chose. And you can go ahead and just unmute and share at this time.
I think Jen is thinking as well. Jen and Clan, I think they're thinking.
Okay, and I like that. So we look at these faces, we look at these pictures, and we start, thinking about what is it about these students. So I'm going to be adding a little more description to these students now. And you're going to spend a little time now and look at the characteristics of these students. And I want you to share with me now, has your opinion changed about who you would like to teach? And I know you're taking a little time to read. So we have Jen, who is always thinking, but never quite has an answer. We have Clan, who shows obvious sign of possible confusion. It could be one of our students with reading challenges, or it could just be that he lacks some concepts, foundational concepts. And then we have Mr. Franno, who is bored with instruction for more than one reasons. All right. And I'm seeing some responses because I see Mr. Grant holding on. I still don't have any preference. All right. And I see Makeda says, okay, that her opinion is still the same. She's still wanting to teach Clan. And, you know, colleagues, I look at these faces, I look at the pictures, and I see still coming in the chat that Tanil is saying they're all teachable. And Mrs. Wallace is sharing is still Jen and no Clan. All right. And, you know, the reality is these faces are representative of the students that we have and the students that will come across, especially at our pathway 3 level. And as we learn, as we come into these sessions, one of the key things we have been even talking about from previous session was that being teachers, we have to be able to identify with our students' interests, our students' learning style, and also our students' content needs. And as we do that, as we learn about that, it is for us to implement a plan. And we would have had a session where we spoke about differentiated instructions. How do we treat to the needs of the varying students that we have? And that is where we looked at differentiation through content, through the process, or through the product. But we would have had long discussion for that. And as Miss Genus is saying in the chat, all just plan for each. And I like that, just plan for each. So as we get into the planning for each, this is what we will be doing. This is what we're going to be treating with now in our session this afternoon. So we want to look at, in our plan, we have to think about what topics are we going to be teaching? How will we select these topics in terms of when we identify certain learning gaps? And then we want to look at, as a teacher, how will we apply effective practices that will help our students to get conceptual understanding? And for this session, we're going to be looking at 5 of our mathematical teaching practices. So I don't know if anybody wants to quickly put in the chat how many of these practices there are. Anybody remembers how many math practices, teacher practices do we have? Any takers in the chat? Or you just want to say it? How many? All right, very good. Wonderful. So we know that there are 8 of them. Thank you so much. There are 8 of them. For the purpose of this presentation, we're only going to be touching on 5 because we know that to do all 8, it is really a lot. But as time goes on, we've always been able to touch on those that, you know, we see most necessary at particular times. And we're touching on these 5: implementing tasks to promote reasoning and problem solving, support productive struggle, posing purposeful questions, facilitate meaningful mathematical discourse, and use and connect mathematical representations. And as we do that, we're going to be looking at online resources that we can use to support the conceptual understanding of mathematical content. All right, so let us start this journey. So I want to hear from you again. Learning gaps, what are they really? Any takers in the chat? Or, as I said, you can go ahead, raise your hand, and you'll be identified and allowed to speak. What are learning gaps, colleagues? We talk about it all the time. Okay, I see Morris, Makeda Morris, your hand is up. You can go ahead, Makeda.
Learning gaps are the difference between what a student is expected to have learned by a certain grade level versus what they have actually learned up to that point.
All right. And I love that, you know, Miss Morris, because guess what? That is something that I encourage my students to do and students to do. That wonderful Google that we have there, because it is so quick to bring up these, you know, to bring us to be able to answer questions. And I love that. So we have that nice definition, which is really what I have here on slide 2. So we're talking about the difference between what the child is expected to learn by a certain grade level and really what they have learned up to that point. Your hand is up again, Miss Morris, or it's just that you didn't lower it? Because I see your hand up, still up. Okay, and I see that because you, and that's really what it is. What is it that our students know? You know, they come to us at grade 8 coming from grade 7, and we start thinking, okay, I can just run with the grade 8 content. But then we realize that there are certain things that are missing, certain things that they didn't get at the lower grade. All right, so we do have what learning gaps are, and we're just warming up now, you know, because I've probably heard 2 voices so far. So I want to hear someone share with me, or even 2 persons, why are learning gaps a problem in mathematics? Why are learning gaps a problem in mathematics? Anybody? Or probably I should ask, is it a problem?
Could I say that it's due to the fact that when it comes down to mathematics, it's a building block, so the foundation must be set. So if the foundation skills are missing, then it's going to be a problem.
And thank you, Mrs. Chambers. And that is so right. And I also see in the chat, yes, it's a problem. And because math is a continuous progression. Math is a continuous progression. And as Mrs. Chambers nicely said it, it's a build-up. All right. So we talk about maths, and we are math educators, we are math teachers. We know that we have some foundational skills that students must know. And as we treat with these learning gaps, we have to be mindful of these foundational skills. And I see Mrs. Thompson says, these gaps hamper progression. All right. And also Mrs. Wilson is saying it will hamper new learning to take place. So our learning gaps will have a negative impact on how our students transition into other concepts. So our students learn other concepts. So it says, without mastering foundational skills, advancing become more difficult, and then the concepts become almost impossible. All right. And I want to, you know, as we go through, we're talking about our pathway 3 students. So I want us to keep them in mind as we really engage and as we really share with each other. So we have a task here, and we want to look at, you know, the way that a child would have presented their solution to the problem. So I want to hear from you. Looking at the response, I want to hear what can you identify that the student knows, and what are some of the things that you're seeing that you can say that this child does not know at all?
Miss, the student knows how to add, miss, but they do not understand the concept of putting down the 4 and carrying the 1, miss.
Okay.
So that would be his or her issue, miss. So once they can make the connection to know that they would carry that 1, then the lesson would have been successful.
Okay. So I'm also seeing in the chat that the place value concept They do not know the place value concept, but they know how to add. And I'm seeing that repeatedly. They're not aware of base 10 numeration. The renaming is absent. The child knows to add single digits. And I'm also seeing regrouping, and the child knows how to add, but doesn't understand place value. And really, as we said, the child knows how to add. I can even go even further to say the child knows numbers greater than 10, because so often we come across our students who some of them are still struggling in identifying digits, but this child knows numbers greater than 10, and also the child understands the concept of the mathematical operation. What is it that the child doesn't know? Just as you said, place value and regrouping in addition. And you have said it, teachers. So now that we know that these are some of the things that are missing, what happens next? What is our next move? Where do we go from here? Where do we go from here? And I just want to get one response and then we move on. Where do we go from here? Anybody? And I know you're still there. So remember, we're looking at scoping and sequencing to treat with learning gaps. So now that we have identified, and I see the chat blowing up again. So I see the place value chart, the place value. So I see that we start thinking about what we're gonna need to treat with, which is treating with the place value. But in treating with the place value, I'm also gonna take you to this very important document. And this is an extract from our grade 7 pathway 3 curriculum, because we must then look at what is in the curriculum. What is it that this child should have done coming up, leading up to he or she being able to do a question of this nature? What is it that the child should have learned? So we go into our document, we go into our curriculum document. And once we have done that, then we start looking at the objectives, which would surround the concept of addition of whole numbers. So quickly, we have 7 objectives here, which are pulled from the curriculum. But which of these would we specifically need in order to treat with the identified gaps? I see number 3, number 1.
Number 3.
I hear number 3. All right, I'm seeing number 3 as well. So number 3 is a recurring objective. And I see number 1, but number 1 says write numerals, word names 0 to 9, and associate with numbers. So remember that the child has already, there are certain objectives that we can say that the child would have already mastered. So we're looking at what are the ones that we need to fill the gap. So I see number 3. So is number 3 the only one? Are we only seeing number 3?
Number 5.
I'm seeing model addition strategies using pictures or concrete objects. All right. And I see persons also pulling in on number 2. And would we stop there? And I see Mr. Grant is saying 3 only. But do we remember the question that was given? All right. And do we remember the response? All right. So the child was able to set out the question properly and we identified these gaps. So really, we know that all of these objectives are important. All of them are important, but we have to look at the ones which are going to treat with the specific gaps that we see. And in doing so, we know that we will end up touching on some of those other objectives that you spoke of. So I see Mr. Grant saying in the chat, the student's response doesn't show any gaps in any of the others, in my opinion. But then let us look at number 7. All right. So number 3 is evident, it's strong, it is there. But number 7 also would be coming into play. Compute and solve problems with whole numbers, because the child is still having some challenges there, right? So we know that once we've identified those identifying our objectives now takes us into the scope and sequencing that we need to do. And I know teachers, many times we have the curriculum document and we would have been told, you know, you need to write a scope and sequence. Even as we get into our 6-week cycle, you know, write your scope and sequences. Identify, you would have done your diagnostic, you would have identified the learning gaps. It is important that we target our teaching, that we are targeted in our teaching. And remember, as we said, math is about building on concepts, building on skills. So we don't want to keep going over the things that the students already know. We want to be taking them up to the higher level. And there's a third objective here that I included. You know, and sometimes I know we'll ask, there are these set of objectives in the curriculum. But if we look at number 3 is not an objective in our curriculum. So is it that I shouldn't have it in my plan? Right? So we're simply saying that, remember that all objectives are important. And if the objective is going to be addressing the need that we've identified, then we have to include it. So we can't just say, but miss the objective then in our syllabus. As teachers, we have to be also flexible. So to include an objective that says use regrouping to carry out addition in column form is just ensuring that that is there, because in itself, regrouping is a concept. So we have place value, 10s and 1s. Good. We will take them through understanding the problem so that they can solve it, they can do the computation, and we'll also be mindful that regrouping is not just something that we just say, once they know place value, they can just snap their finger and regroup. We have to be mindful as teachers that at this level especially, and as a matter of fact, just teaching mathematics conceptually, regrouping in itself is a concept. And it must be that we spend some time to ensure that students understand that concept. So the scope and sequence document, it's the one that describes what are the skills that the students will have to be exposed and learn. What is the content that the students will have to master? As they transition through the objectives, it must be that they're progressing. And that's why we say it needs to be in a progressive order. All right. So I just want to keep that in mind as we look at how we scope and sequence topics to treat with whatever learning gaps we identify. And I know that once we have passed the diagnostic stage, a lot of what we will identify will come through the way students respond. Good. So as we said in this session, and this is one of the objectives that we would have had in relation to our session today, is that we are looking at how we scope and sequence to treat with our learning gaps. And now we're going to be transitioning to exploring now our teaching practices that support students' conceptual understanding of mathematical content when using the virtual or face-to-face teaching modality. So for this session, as we progress, we have selected 3 areas. And we have extracted objectives in relation to these three areas from our grade 8 syllabus. So grade 8 term 1, and these are pathway 3 curriculum documents, division of whole numbers. Then in grade 9, we're looking at computing fractions, and this is in term 2, unit 1 of our pathway 3. And then we're also going to be looking at converting metric units. And this is in our grade 9, term 1, unit 3. So these 3 areas, we're going to be going through these 3 critical areas and topics in math, or concepts in math, that we know from experience that our students have challenges with as they try to get conceptual understanding. So For the division of whole numbers, as we said, it was taken from the grade 8 syllabus, and the objective that is there says divide 4-digit whole numbers by a 1-digit number with or without regrouping or remainders to get a 4-digit quotient, a 3-digit quotient. And at this time, I'm going to hand this section of the presentation over to Mr. Johnson.
Okay, thank you so much, Ms. Townsend. I don't know if the participants have any questions for you while I prepare to share my screen. You can go ahead, participants, if you have any questions for Ms. Townsend. All right, so I want to start off engaging us in a scenario. Is Mr. Palmer, and looking at the objectives that Ms. Townsend just mentioned, Mr. Palmer is looking at the division of whole numbers, and he has been looking at this concept for a while, and now he wants to give a challenging task to his students. And so we want to take a deeper dive into what the tasks look like. So he has an option. He has two options, right? So he can present this activity that is entitled the Orange Orchard. And so we can go through the activity. Mr. Benji owns an orange orchard. Help Mr. Benji to share 1,000 oranges in 4 equal parts. So we want you to engage in the activity, participants. So I'm just going to give you 60 seconds, 1 minute, to just engage in the activity. What is it that you think that student could have done for this activity? So it is very important that you try the activity for yourself so you gain an appreciation of the activity. Okay, wrapping up at this time. All right, good. So please retain your responses at this time. All right, so I think that you would have engaged in the activity. So this is one of the tasks that he's considering in giving his students. So now let's look at the other one. So this one is entitled The Orange Farm, and it reads, 4 men are to share some oranges evenly among themselves. Determine the number of oranges they should pick individually and all together. Now, Mr. Palmer has some guided questions for which he feels that he would use to scaffold the students' understanding as they engage in this activity. For example, what numbers from 50 to 100 can be evenly shared among the men? How can the 4 men be sure that the total oranges picked will share evenly? What rule can you develop to determine when it is possible to divide a number by 4, leaving no remainder? Kindly engage in the activity for a minute.
engage in the activity, I just want to remind you of the register. It has been placed in the chat, and I'm going to repost it once more, just in case persons came in after it was last posted. All right, so please ensure that you register, you write your name, or you follow through with the attendance register. Thank you.
Okay, thank you, Ms. Townsend. So here we have the activities. We have brought them back for us to look at. And we want to say, which task would you give to your students as a challenging task and why? So now feel free to put your comments in the chat and also to open your mics and speak. So having engaged in the activity, you would have gained an appreciation of the activity. So now we are looking now, we want to say which of the two, you would give and why.
Just to say, Mr. Johnson, just before we start getting some other comments that persons would have written before when you gave the first task, that students can put them into groups of 4. We got a lot of divide 1,000 by 4. I also got from Miss Spencer, says section the orchard into 4 rows or columns.
Okay,
and
some
so
presentation there.
Right, I did see that coming out in the chat.
All right, wonderful, thank you. Based on those responses, it would seem that it would have been for the Orange Orchard, that activity where they're supposed to divide the 1,000 by 4 in 4 equal parts. All right, so we have presentation coming out where persons are looking at creating rows to represent the information and their understanding, which is very good, very important. We will definitely touch on that later on in our presentation. Can we have something for the Orange Farm? What about persons who engage in that activity?
Well, what I'm seeing now, sir, are persons answering this question. So I have Mrs. Wilson saying the second task as a task which would be challenging. Would you give to students as a challenging task? And I also see Miss White saying first task. So would have gotten 2 responses, but then 2 opposing responses. So I'm waiting for more, sir, to come in.
Okay, wonderful. So we have persons saying that the Orange Orchard would be the more challenging task as opposed to the Orange Farm, and persons saying the Orange Farm is actually the more challenging task. I would want the reason behind it though. So for the persons who said that the Orange Orchard is the more challenging task, can you give us a reason to justify this, please? And likewise, the person who said the Orange Farm is more challenging, can you share your reason why? Or anybody who feels that, a particular one is more challenging or is fitting for a challenging task. All right, no takers.
I guess for the purpose of smooth flow, I'll give it a try. I guess persons would think the Orange Farm one is more challenging simply because there is not necessarily a single correct answer. Because based on what I'm seeing here, it leaves students the opportunity to determine how many oranges they should pick. And by virtue of determining how many oranges, I mean, it could be any number because there's no cap on how many oranges are available. And it could be any number. And then based on what they decide, each individual should pick, they would have then ultimately decided for themselves what the cap is. That activity lends itself to a number of possible right answers. That forces the class now to understand the relationship between, I guess in this case, factors, products, and then in the reverse, what them name again, quotient. Well, how factors, products, and quotients are related. Whereas the first one is a bit more funneled. It feels more like all you're thinking about. Yeah, it feels more like this is your cap, this is how you need to achieve it. And so in my mind, the students would only be thinking about quotients, dividends, and divisors, whereas the other one is a bit broader.
Okay, thank you so much, Mr. Grant. And I see Mrs. Alison Wilson agreeing with you in the chat as well. So thank you. We are putting the task again, and now we're going to ask some specific questions. How did the task allow multiple entry points and varied solution strategies? So looking at both tasks, we're looking at how did the task allow multiple entry points and varied solution strategies? Or did both tasks offer those things or just one? All right. Anybody want to give it a try? And I'll just put the next one on it. How was problem solving and mathematical reason promoted in the task? So you mentioned, Mr. Grant, that, one task kind of felt like you're funneling their understanding, or you're probably kind of limiting them. And then another task felt that, they have more options. So are you saying that even that speak to differentiation? Did students who are probably not so good at working with larger numbers could actually start something, where they're at? Talk to me.
Definitely,
yes,
I
Sir
agree.
Johnson, definitely.
Yes, yes. Thank you so much. So which of the tasks would offer the multiple entry points and varied solution strategies? And do we understand those terms? I think Mr. Grant intended to
Task 2.
Okay. Task 2. Okay.
Yes, I agree. Task 2.
Yes, Mrs. Lindsay. And having engaged in the task, are we able to see the multiple entry points where students who, no matter where they are at in terms of their understanding, could probably start something? So it is what we would call low floor, where every student, or most students, we hope that every student would actually be able to start something. If it's even, they're going to start with a particular number, a low number of oranges, probably under 20, and then work from there. All right. Varied solution strategies. Mr. Grant mentioned that there is no possible one right answer. So for the second one we're looking at here.
Sir Johnson, pardon me, and if I may interject, with task 2 as well, it allows for more mathematical discourse to take place.
Okay. Yes, yes. You want to further explain?
Not really, but I will since you asked.
All right.
Yes, because of the different entry points that the students will have. Once you go into the explanation section now of this lesson, you will be getting the different entry points that the students took, and you'll be finding out the relationships that they created based on the activity. So it lends for more discourse within the class, and Let me tell you, I would love to be a part of that class.
All right. All right. Very good. I'd love to be a part of the class too. All right. So we are going to look at this the third phrase there, problem solving. And problem solving, we want to take it away from just the word and how wordy, or, you know, we have some symbols, some numbers, and we put them in word and then we say that is problem solving. That is not what we're looking at here. And so the true essence of problem solving is student not being given like a procedure or an algorithm, and they are supposed to actually read the problem, understand it, and determine, you know, how they're going to solve the problem, right? And so one way I look at it is that, you know, problem solving, if you are going from Mandeville to someplace in Kingston, probably Devon House, you're going to Devon House, but you have never been there. I don't give you an app, I don't give you a roadmap, and you need to get there. You have to make your own way there. Find, you know, you have to solve that problem, as opposed to I probably give you an app like Waze, where it tells you you need to go 800 meters, turn right, turn left until you reach the destination. You have a procedure and an algorithm there. And so that's how I wanted to look at the problem solving. So Mrs. Lindsay just mentioned mathematical reason, so I'm not going to go in further in that. But I hope that we can appreciate that the second activity would actually cater more to problem solving, the multiple entry points, the varied solution strategies, and mathematical reasoning. Thank you. So we move on. So this is the activity was actually used to bring out the second mathematical teaching practice, which is called implementing tasks that promote reasoning and problem solving. So we are going to look at the statement from NCTM, and I want you to help me to fill in the blanks. There are some word, one particular word that is missing, and I just want you to just either put it in the chat. So Mr. Townsend, you can look at the chat, or you can open your mic and tell me the words that are missing. So we're looking at the first one. So effective teaching of mathematics engages students in solving and discussing blank that promote blank. So we're looking at the first blank. Discussing, anybody knows that one or can guess that one?
Nothing in the chat as yet for this, but what I can tell you, there has been some very good discussion even on, you know, the points that you would have been sharing earlier. So I also like what is happening in the chat, where persons are really pretty much on point, the same points that you would have shared, but nothing yet.
All right. So I'm going to give them the first one, Ms. Townsend. So tasks. So it begins with the tasks, right? Implementing tasks that promote reasoning and problem solving. So we're continuing. So solving and discussing tasks that promote blank reasoning. Anybody get it yet?
Well, I'm sure you gave away one just now, but I'm sure I heard one. All right, I'm seeing math solving entry effective.
Math, so
reasoning,
problem
solving, and multiple entry points and effective solution. And that's Mr. Grant. I see.
Okay.
I see.
Only the varied. All right.
Right.
Continue.
And I would have seen on some other single responses. They're coming in, but I guess pretty much you have filled it in for them.
All right, wonderful. Thank you so much, participants. And so, so we have some words that are highlighted that, you know, are key to understanding the practice that they, and if you didn't know, or, you know, I'm just reminding you that these are teacher practices, whereas the the mathematical practices that we talk about would be like student. These practices that we're talking about now are actually teacher practices. So this one begins with the task, the type of task that you choose. And of course, you would have realized by now that the second task that has the multiple entry points, that has the varied solution strategies, those are the ones that bring out the problem solving, right? And engage students in rich mathematical reasoning. So we're going to continue with the scenario with Mr. Palmer. All right. So after students have been engaged in the task, the orange form, the second one, some students began asking questions, began asking for the answer, right? So you know those students that as soon as you give them a task, they don't know what to do. They start asking you what to do, as if, because sometimes they are in a culture where that's how they see math. They just get to the answer and they don't enjoy the procedure. All right, so here we go. What is Mr. Palmer's next action? So we're going to give you some options and then you are just going to say which one you think would be best for him to actually bring out, the whole, give them a challenging task and experience. So we have on the left, provide options and various ways the students can tackle the problem, or visit the groups to see the various approaches students are using to enter the task. Which one and why? We don't want to spend too
Right
long.
off the bat, I see Mrs. Wilson says blue.
All right, all right. So the blue one, any justification for that?
And I see visit group as well.
Okay, okay. So persons are saying that visit group. Okay,
visit
so it's
group
still a blue.
and blue.
Okay, all right. So here is a very important practice. It says that, giving students time to struggle with tasks and asking questions that scaffold students' thinking without stepping in to do the work for them. So this is what we want to get out of this one. That is very important. We must give them time to struggle. So we must set aside time for this. So here we go again, continuing. Mr. Palmer noticed that some students did not know how to start the task. What should he do next? So Mr. Palmer could ask questions to focus their thinking, that student thinking. For example, how does today's topic relate to our task? Or Mr. Palmer could ask some funneling question. Mr. Grant mentioned those. Example, if there are 4 men, what number should you divide by? Talk to me. Yes, Ms. White.
Those can be done based on the group that you are using, or based on the group that you are visiting.
Yes.
Yeah.
Okay, so what you mean by based on the group that you are visiting? Explain further.
All right. For example, remember that we have different levels of students within the one class, and they are in different groups. So based on the group that at that point, the differentiated level of that group, you would know if you need to ask the following question, or you ask questions that will focus their thinking. Based on your knowledge of the student, then you would know which one is best.
All right, all right, all right. And I appreciate that. I appreciate that. So in essence, you're saying then that there is a place and a time for funneling question, and there's also a place and a time for focus question. Is that what you're saying as well? And also based on the student?
Yes, that's what I'm saying.
All right. So let us relook at what Mr. Palmer is trying to achieve here, because he would have engaged students in the concept of division of whole numbers. And now, they have done the procedure and you think that they have had the concept to a certain degree, now he's trying to challenge them. So let us remember now that he is really trying to implement the tasks that would challenge them. and he's also doing something else that is bringing out another mathematical practice. And so it's the same thing as teacher practice, as we would have discussed before, where he wants to focus their thinking without actually doing the thinking for them. Because, you know, if you go in and say, all right, you need to divide by 4, the teacher would have, you know, invariably done this thinking for the child. So all he needs to do now is just divide by 4, all right? Continuing. So here we have again. So additionally, now Mr. Palmer wants to provide some additional support for his struggling students. So he realized that some students are struggling. So what should he do next? Demonstrate the process of division by 4 without leaving a remainder, or provide a 120 chart for students to color numbers divisible by 4 and note visible patterns. Talk to me.
Okay, Mr. Johnson, so in the chat, Mrs. Wisdom says he wouldn't use the 4, but another number, for example.
Oh, okay. Okay. Was that to what I said previously? About dividing by 4?
Yes.
Oh, okay, okay. Kind of scaffolding them. Okay, I see. I see. Yes. Was somebody saying something?
All right, so in the chat, I'm seeing blue.
Okay, blue. Anything? Why blue? All right.
I see red as just telling.
Oh, you feel that red is just...
They're not finding out. Then you're giving them the answer. They need to find out for themselves. So you giving them the 120 chart and students looking at the pattern would be a better way to go.
Okay. All right, wonderful. And so you're not just going to just throw a question like this of nature on them, you know, without properly planning, you know. So you're going to anticipate your student. You know your student and you know what they're going to be struggling with. And so you're going to anticipate providing them with supporting materials that they can use themselves to figure out the task that you have given to them. All right. And thus we have this statement here. All right. So very, very important. Thank you for your participation. So we have one more. So obviously we have students who normally be frustrated in class and complain a lot. So what should be Mr. Palmer's next action? So in blue, help students to discuss their mistakes. In black, give the students several possible answers and ask them to find others. So in a sense, I'm just going to show you some correct answers. 100 would be one of the answers. And you just give them several answers and say, all right, find your own. What do we say?
Blue, sir.
Blue.
All right, anybody want to say why?
It's a pity you put the telling one in black. Don't discriminate against the black.
All right, all right. Okay, so thank you. So helping students realize that confusion and errors are a natural part of learning by facilitating discussion on mistakes, misconceptions, and struggling. So, you know, I don't know if, you know, our students appreciate mistakes. You know, when you make a mistake, what really happens, you know, the connections that are made in your brain. So even neuroscience, we're not going to go into that, right? But once you make the mistake, you know, they can actually learn more as if just making the correct answers going right across the board, all right? Okay, so here we have know that, the students are, some students are a group created a table with many heroes though. They were trying to show some possible numbers that are divisible by 4 and some that are not. But Mr. Palmer realized that there are so many errors in the table. So what should he do? Check to see if the answers fit the task and mark those that are correct and incorrect, or he praised the efforts of the group and encouraged them to persevere. What do you say?
Purple, sir, purple.
So we have purple. Anybody saying black? All right. Any reason in there in the chat, Miss Townsend?
Well, what I see purple, and then I see for those who make no attempt, they'll make no mistake.
Oh, okay. All right. So praising students for their efforts in making sense of mathematical ideas and perseverance in reasoning through problems. So we come to the 7th mathematical teaching practice, which is support productive struggle in learning mathematics. Effective teaching of mathematics consistently provides students individually and collectively with opportunities and supports to engage in productive struggle as they grapple with mathematical ideas and relationships. So we have brought you to this one. So we hope that you can appreciate. We are not going to go through these questions, but they are very important because it is, I just wanted to think about them. What can you do to consistently engage students in productive struggle in your class? What opportunities can you provide your students to engage in the practice? What support can you, or supporting material, can you provide your students while they engage in the practice? So think about those questions. All right, so at this time, we want to engage you with 2 manipulatives that could, you could use in your classes. The 120 chart. So some of you would have been used to the 100 chart. You have the 120 chart, and this is an example of, what the student would have done in Mr. Palmer's class in trying to find numbers that are divisible by 4. And so obvious patterns would have been seen right there, right? So if you go down, look at those in green and look in blue, we could see those multiples of 4. The base 10 blocks. So if you have a division issue with your student and you want them to see it visually, we have, for example, here, the area of these blocks represent 440, and you need to divide by 22. And so you can just create an area model by length times width, where the length is shown there as 22, the divisor. And of course, they would just count the other side, the width, to get the quotient of 20. So just going to do a new share to just take you to the screen to just have a quick look at these, to have a quick look. Let me go back again. All right, so all right, so just trying to get it up. I don't know why my screen keep on coming back here. Just gonna try it one more time, colleagues, and then we'll move on. So we're just trying to let me just get these things off the screen. So in the meantime, colleagues, those who have not signed the register, please go ahead and sign the register.
I've also placed in the chat, Mr. Johnson, links to both the 120 chart as well as the blocks. So colleagues, you can go ahead and, you know, copy those links and share and place them somewhere if you do not have links, if you do not have, you know, a link to a 120 chart, etc. as yet. All right.
All right, awesome. Okay, so are you seeing the new screen, Ms. Townsend?
Yes, sir, I'm seeing the YouTube currently.
All right, so I am trying to navigate, but my system is a little bit slow on the end there. So let me see. Okay. So navigating to the, so this is an example of what the 120 chart looks like. So hopefully you are able to see here on the top right, the students have options of coloring. And so if you're going to send the student the link to this site and you want them to engage in this, this manipulative, you can do so. Or if you know you want them to present in class, somebody share their screen and as a group you're going through so that they can color patterns with different colors. They can circle certain numbers. So probably they're looking at the relationship with the numbers that are going down. They can count on for those students who have issue with counting. Probably give them 15 plus 30. You can start at 15 and they can count on. The other one, they have lost the site for the base 10 blocks, but some of you are familiar with it. Sorry about that, but due to time, we just have to move on as my system isn't working so efficiently right now. So I'm just gonna ask Dr. White to just come on and carry on with the presentation. Thank you.
Okay, so as Dr. White prepares to share, I just want to remind you colleagues that the attendance register, the link was shared in the chat for those persons who may have joined after. Mrs. Wisdom would have just reshared for participants as I saw some persons typing out their information in the chat. So if you could just use the link. Thank you. I think Dr. White is ready. Go
okay,
ahead,
good
Dr. White.
afternoon. Good afternoon again, everyone. We have just gone through implement tasks that promote reasoning and support productive struggle. So we're going to be moving on. So we're going to be looking at computing fractions, and the objective is to add, subtract proper fractions with unlike denominators that are not factors or multiples of each other. So I'm going to take you through a scenario. It says Mrs. Wilkes was conducting a review session on addition and subtraction of fractions with like and unlike denominators. The students were more comfortable with fractions with like denominators. However, most of them struggled with fractions with unlike denominators. The review session was in preparation for the 6 weeks assessment. So let us listen to the discussion with Mrs. Wilkes and her students. And my colleagues will be assisting me in this. Good day, class. Today we will be reviewing addition of fractions with unlike denominators, but let us first look at fractions with like denominators. Can you give me an example of two fractions with like denominators?
Yes, miss. 2/7 and 4/7.
Is this how we name fractions, John?
Don't remember, miss.
Is there anyone who can help John?
Miss, it is 2/7 and 4/7.
Thank you, John and Mark. Now, what about fractions with unlike denominator?
Miss.
Sorry, I'm sorry. I think
2/5 and 1/3.
Okay, thank you, Annie. Let us look back at John's fractions, 2/7 and 4/7. How could we add these fractions?
Miss, add the top numbers and add the bottom numbers.
Class, do we agree with John?
No, miss, because the denominators are the same. We keep the denominator and add the numerators.
Is there anyone who could do a representation to help make it clear for everyone?
Yes, miss. 2/7 or 2/7 plus 4/7 equals 6/7. So in total, we have 6 1/7.
So how could we write that, Mark?
6/7, miss.
Okay, thank you, Mark. Are there any questions? Now, let us go to Annie's fractions with unlike denominators. She had 2/3 and 1/4. How can we add these fractions?
Miss, we would write out the fractions and add them up, miss.
Mark, can you explain what you mean by add them up?
Yes, miss. 1/3 plus 1/3 plus 1/4 gives me 3/7, miss.
Mark, please explain how you arrive at 3/7.
Miss, you see in the first one, because all of them are over 7, we only have 7 and then add the top number. So, miss, because two of this one have 2, 3 at the bottom, I add the top number and get 2/3, and then add the other one at the top to get 3. Then add the 3 and the 4 at the bottom to get 7, miss. So I get 3/7.
Okay, thank you. Now let us first talk about top number and bottom number. Is this how we refer to a fraction?
No, miss, it is a numerator and denominator.
Thank you, John. What about naming the fraction?
It is 3/7, miss.
Thank you, Annie. Now, is this how we add fractions with unlike denominator?
Miss, I think the fractions should all have the same denominator for them to add.
How is that done, Annie?
Miss, find a number that we can use for the two denominators.
Great, Annie. So how do we get that number?
Miss, you said we can find the LCM.
Can you explain what LCM means?
Yes, miss. Find the smallest number that the two denominators can go into without leaving a remainder.
Okay, Annie. Can you tell the class the smallest number that 3 and 4 can go into without leaving a remainder?
Yes, miss, 12. So change 2/3 to 12s and 1/4 to 12s, miss. Then add the numerators and keep the denominator because they are the same, like this, miss.
Well done, Annie. Good job, students. Now, let us discuss. What are your thoughts on the slides presented? 2 questions I have for you. And how may we apply mathematical discourse to enhance students' thinking? Talk to me. Teachers, participants.
Honestly, it was interesting. I like Mark's train of thought. I had to smile when I was listening to, well, watching and listening to how he puts it in his mind, or I think it should be. And in reality, the students really do that.
Thank you, Mrs. Wisdom. Anybody else? One more? Just one more comment.
I like that the teacher probed the answers from the students. She didn't just tell, she asked, and also for them to represent it.
Thank you, Mrs. Wilson. So how may we apply this course to enhance students' thinking? Just one comment and then we'll move on. Anybody? Just one person, then we'll move on. Anybody? Anything in the chat, Ms. Townsend?
Not yet, Doc.
See my work? Miss Neville.
All right, somebody's mic is open. We are hearing your conversation. Okay. Could I get one comment, please?
Okay, there is a comment in the chat, Doc. It says by asking questions.
Can you qualify questions?
Probing questions, open-ended questions.
Thank you very much, Mrs. Wilson. It's very important that we ensure that the questions we ask, and I heard it discussed earlier, is not just funneling questions. They may have their place, but to a minimal. And so we have to ensure that when we ask questions, we are probing and we are giving the students a chance to think. So let's look at this. Effective teaching of mathematics facilitates discourse among students to build shared understanding of mathematical ideas by analyzing and comparing student approaches and arguments. I think I heard Mrs. Wisdom said it at the beginning that it reminds her of students in her class. And that was the intention, because this is what we see every day. But are we going to get frustrated and say, okay, let me just tell you, or let me just ask a funneling question, you know, and just finish it? We have to develop what we call meaningful mathematical discourse. That's math teaching practice 4. We have to learn to facilitate meaningful mathematical discourses in the classroom. Now, I would like you to answer this question. Was this teaching practice evident in Mrs. Wilkes' class discussion? Explain. Don't just say yes or no. Anybody? Did you see any evidence of this teaching practice? Math teaching practice 4.
Yes, Miss, because she corrected the students in terms of using the mathematical language.
Thank you very much. Thank you very much, Mrs. Wilson. So it's not just about saying you are wrong or you are right, or like I said, asking funneling questions. Develop a discussion that will guide the students as they think about what they are doing. All right, so meaningful mathematical discourse, it provides students with opportunities to share ideas, clarify their understanding, and develop convincing arguments. If you remember what Mark was saying, Mark was convinced about what he was saying. What we did before, we're going to do it again. So in talking with Mark, you get an understanding of what he is thinking. Mathematical discourse also, or meaningful mathematical discourse, also advance the mathematical thinking of the whole class by talking and sharing. And if you notice, when one made an error, the other one was able to correct it. I think it was John who made the error and then Mark corrected him. And you see, when peers correct each other, it is very, very effective. And I'm sure you know that. So the teacher should strive to engage students in explaining their mathematical reasoning in small groups and in classroom situations. Also, facilitate discussions among students that support making sense of a variety of strategies and approaches. So that's meaningful mathematical discourse. Yes, somebody's saying
We'll
something.
move on, Doc. We have in the chat, exercise patience and allow students to be actively involved in teaching and learning. And
definitely.
there is an hand raised too.
Okay, very, very good. Wait time is extremely important. You might, sometimes want to move on and they are taking so long, but give them chance to think. Give them chance to think about what they are saying or what they want to say or what they are writing. All right, take the raised hand, Mr. Johnson.
Ms. Wilson, Mrs. Wilson, you can go ahead.
Yes, sir, thank you. I love the fact too that the teacher didn't put down the student when the student made an error. She commended the effort and but asked if everyone else agreed and what would correct this person.
Excellent, wouonderful. And we have to be careful about how we address students' mistake, because that will just throw them off and they wouldn't want to participate in any class, because of course the peer is going to laugh and all of that. So thank you, Mrs. Wilson, for noting that.
And Ms. Wallace is saying how the students correct their peers is work in and of itself is correct to get the student to actually correctly correct students, their peers.
Definitely. Thank you. Did you know that a student who can explain what they did or what to do understands the mathematics and may have a better chance to succeed at a less familiar task? And that is why I like journaling, because I like when students write what they are doing, talk about it. There you can see where they are making mistakes. Did you also know that one way to deepen conceptual understanding is through the communication students have around the concept, strategies, and representations? And I'm sure as teachers, you sit down sometimes and listen to them having conversations, and then you have to jump in because this one correcting that one, but what the correction is not the correct thing. So it's really good to have them talking with each other and listening to their conversations. So math practice, teaching practice 5, purposeful questions. Were the questions Mrs. Wilkes asked helped to build on and extend student thinking? Explain. Even if you think you said it already. Anybody? Were the questions asked?
Nothing yet in the chat.
Pardon?
Nothing yet in the chat, Doc. We have yes from Miss White.
Miss White, can you say explain why you say yes? If you can remember one or two of the questions or anything that was said, why you say yes? Miss White? Anybody?
We have a yes again from Miss White. So
Miss White, can you just say something why you say yes?
I don't know if she's unable to speak at this time or something like that.
All right, okay, let's move on. Did the questions reveal students' current understanding of the concept? Explain. Anybody? I just need one person to answer.
Yes, Miss. The questions did. Both for the student who had the wrong concept and the one that had the right concept. Based on the question that I was asked and the answers given, the teacher was able to realize that the student didn't have the right concept and this one had the right one. So yes.
Right. Thank you. So by communicating or developing the discourse, you know exactly what they are thinking, allowing them to speak, you know exactly what they are thinking, and so you're able to make the necessary corrections. Thank you. So effective teaching of mathematics uses purposeful questions to assess and advance students' reasoning and sense-making about important mathematical ideas and relationships. Asking purposeful questions encourage students to explain, like they all did, elaborate, that was evident too, and to clarify their thinking. I like what Mark said, because he clarified what he was thinking based on what was done before. Okay, so I'm gonna take you to a resource that can help students with addition of fractions with unlike denominator. And so I'm going to do a new share, and I hope mine work. Okay. All right, I don't know if you have used this before, but let's take the 2/3 plus 1/4. So this, you could use this with your students. So notice these are all numerator 1. So if you want 2/3, you would need to put up 2/3, and this is toy theta. And Miss Townsend will put it in the chat, I'm sure. And you're adding 2/3 to 1/4. So there you have it, 2/3 and 1/4.
Before would not be fractions as well.
I didn't hear that.
I've used it before. I've used it with place value and such, but not with fractions as well.
Okay, wonderful. So you have 2/3 and you're adding it to 1/4. So Annie said, make the denominator 12. So you look for the denominator 12, and you say how many 12s can fit into these fractions up to up to where 1/4 is. So you're going to fit as many. And let's say a child did not know if it was 12. They could play around. Let me just take back these on a minute. Miss Townsend, do I have like another 2 or 3 minutes?
Yes, Doc.
All right, so let's take another fraction. I don't know that I should use 12. So I'm going to use 8, because it seemed to me like 4 can go into 8. And I'm not mindful about 3. I'm thinking about 4 right now. So I'm going to take the 8s and I'm going to pack them and see how many, if I can get the 8s to pack in the second line and end where the 1/4 ends. It should not be less, it should not be more. So there I have it. It's more than, it fills more space than what I have there, than where the 1/3 and the 1/4 is. So if they don't know exactly what to use, they can play around until they find the solution, and then they will know, oh, so I should have made the denominators 12, right? So you don't have to coerce them into this, allow them to practice. So I'm going to take these out. The only thing you have to take them one by one, so it takes a little time. And so maybe somebody would have taken 1/6, or maybe somebody would have taken 1/4 and tried to pack them. But they will realize at the end is either it's going to be too small or too large. So I'm going to pack the 1/12 and see if it will fit. Pardon? Or 1/7. I like that. I like that, Mrs. Lindsay. That is so true. Okay. And continue packing to see how well these fit. And there should be no leftover in either of the 2 lines. So there I have it. I have packed them and I have the 12s fitting. Now, how many 12s did I get? And you could use this at the beginning. After they have developed the concept, then you could move away from this. But this is very good to help students who are, you know, having challenges finding common denominators for unlike, for fractions with unlike denominators. Okay? So I'll, okay. All right, I go back to the presentation. Okay, so that was a resource that you can use in helping the students. All right, thank you. So we have looked at purposeful questions and we have looked at facilitate meaningful discourse. So as we continue to explore, teach, any questions, by the way, before I move on? Any questions, comments?
No, Doc, just a comment to say this will also help students with their estimation of answer.
Wonderful, thank you. So as we continue to explore teaching practices, I'll now hand over to Ms. Townsend, who will take us into the next practice. Use and connect mathematical representations. Over to you, Ms. Townsend.
Okay, thank you, Dr. White. All right, so we know that so far we are looking at the different teaching practices that we can use as we help students to develop conceptual understanding. So we have so far looked at the division of whole numbers. We have also looked at calculating fractions and the demonstration there, clearly doing additional fractions. And now we're at our third math concept that we know that teachers often have challenge getting across the students, and that is converting metric units. So in the grade 9 syllabus, there are basically two focus areas: centimeters and meters in relation to kilometers. And as such, we are just going to be focusing on those parts for this part of the presentation. So here we have Joseph, and she's a student in grade 7, and she was asked by her teacher to say the number of meters in kilometers. So I want to hear from you, how would you solve this problem? You know, you are doing, and I want you to do the problem. I want you to share in the chat, or if you want to just unmute and just tell us, how do you do this problem? I'm talking about you now. So I'm thinking of you, not necessarily how Joseph would do it. You can put it in the chat, or you can, if you want to feel comfortable to just unmute and share, you can go ahead. Okay, so already in the chat, I see 5 times 1,000, which is equal to 5,000 meters. Thank you, Mr. Grant. And I'm thinking, did I hear on mute just now? Somebody wanted to say something?
Yes, I would equate the meters to kilometers. So I would say 1,000 meters equal 1 kilometer. So therefore, or I would say 1 kilometer is equivalent to 1,000 meters. Therefore, 5 kilometers would be equal to 1,000 times 5, which would be equal to 5,000 meters.
And very good, because really we look at, and I see Mrs. Wilson typing out the same explanation there, that we would go from the equating of 1,000 meters to 1 kilometer and then follow through with multiplication. But how is it that our students knew how to do that? How did this conversion, this relationship establish? Where did it come from? Where did this relationship come from? So here we have Joseph now. I'm still having another question, but this time she needs to know, say, how many cones would she need if she were to place them 2 meters apart on a 5-kilometer stretch of road. And what I want you to think about, the method that you used previously for the previous question, how could you use that same method to solve this problem? And I see Mrs. Wilson, where you've also demonstrated addition. All right, so repeated addition. So instead of multiplying by the 5, you would add 1,000 5 times. So we're using 1,000 meters is equal to 1 kilometer. And we would have used multiplication to get the 5,000, or we would have used repeated addition, as Mrs. Wilson would have shared. But now we have another problem. How can we use that same approach? Or maybe I should ask, can we use that same approach?
Yes, we could, Ms. Townsend. We could now divide the 5,000 meters by 2 meters to see how many cones, we could use.
Okay, and I also see Mr. Grant actually doing the math there in the chat as well, where he would have done the same, basically follow the same line of reasoning, the same procedure, and would have ended up with the 2,500 pounds. So we think about conversion in mathematics, and we think about, you know, the whole conversion of units. And what would be a representation? So we've done it in our algorithm format. What could be a representation that we could use with Josette to help her with this problem? You know, let's say Josette is really one of those students who, it doesn't matter how much time you tell her 1,000 meters, you know, that's a tell. 1,000 meters is 1 kilometer. It is just not sticking. It's just not staying with her. What representations could you use? All right, I see Mrs. Wilson saying a number line, and I'd love to hear Mrs. Wilson. You know, so I say, if you so feel, you can put it on a paper, you can put it on paper, and you can open your camera and show us the paper, how you would actually draw it up. I see Mr. Grant saying a ruler. I see Mr. Grant also saying non-standard bars. But I want you to share with me, Mrs. Wilson, I would love to hear from you in terms of a number line. How would you use a number line representation to help the student? Okay, so Mrs. Wilson, all right, so she's having a little challenge this time. But anybody wants to share? Have you ever used a number line when you're teaching metric conversion? Anybody else has ever used a number line? I don't know if Mr. Grant wants to share with us how he uses the ruler to assist in conversion of metric units.
Really, because if you get, doesn't have to be a ruler, but if you get any instrument that uses standard units, 2 different standard units, for instance, you could just compare the numbers from one instrument with the other, with the expectation that Josette would see where we get this idea of this is equal to that. So she gets the idea of this number of units is equal to that number of units. This is how we've come about this whole comparison thing. And then I guess the whole conversation about larger units of measurement now, like meters and kilometers, that now would be introduced as facts that we've known, we've been able to prove, but it's a little bit difficult to show her right now, just because 1 meter is a very a very long distance, and we probably don't really have that to compare 1,000 meter to be a kilometer.
Okay.
I don't know if I confused you.
Not at all, Mr. Grant, and I hope I heard you clearly, and I held on to some points. We hope she will get it and understand it and be able to make a relation, and the challenges we may have even in this space to establish that 1 meter in reality. And I see Mrs. Wisdom says, ask her to measure her room, thus making it practical for her. And I noticed, I think I saw Mrs. Wallace's hand up earlier. Mrs. Wallace, is your hand still up? Is there something you'd want to share with us?
Okay, you were asking about the ruler, and I was saying, yes, I have used the ruler before to teach the conversion. We look at millimeter to centimeter, to have them looking at the smaller strokes and how they add up to make the centimeter.
Okay, yes.
And with what he's saying, that you couldn't probably give them the whole kilometer for them to see it. But like if they know different guideposts along roadways that are commonly traveled that are really marked, you could say to them, all right, if you travel from this point to that point, you notice from that point to the other point how many you notice, and then look now to see on your play field. So I use like their play field to say, all right, how the football field is drawn, how much meter they say it must be at which part. So I infuse it with their sports.
Okay, thank you, Mrs. Wallace. And I see Mr. Grant's hand up, but what I hear from you, Mrs. Wallace, is making it practical to them, bringing it home to them, allowing them to be able to relate to it in their environment. Okay, Mr. Grant, let me just hear from you and then we're going to move on.
Yes, Miss. Just in case I wasn't clear, so what we would be trying to achieve from what we're sharing in terms of using the ruler is not necessarily for them to see every time how this is equal to that, that is equal to that. But we use what we call a simpler problem that we're able to represent so that they can see and understand the whole comparison between one unit and the other. So the goal at that point is really to get them to appreciate how 1 centimeter, no, simpler one, how 10 millimeters can be compared with 1 centimeter. And from that, how 20 millimeters can be compared with 2 centimeters. Over time, a pattern would be established, and then we can use that now to extend to more abstract ones that are harder for us to model, like the meters and kilometers. In that sense now, in that case, we would have to give them the comparison and have them accept it as facts.
All right, Mr. Grant, I'm happy we're going down that road, you know, where we're going to get them to accept it as facts. And I like the discussion, and I also see some material being shared in the chat. So, you know, we talk about all of these ways that we build. And I'm wondering, have we ever tried exploring the unit prefix relationship? Just a quick yes or no. Is there anybody? We're not going to really talk about it. We're going to go straight into it. And I see Mr. Grant says yes. And I know that you will have a lot to share, but let us just, and am I seeing any other yes? And I'm seeing yes from Mrs. Wilson as well. So let's just ride along. And I mean, as I go along, if there is something that I may be leaving out, feel free to just stop me and say, boy, Miss Townsend, you didn't, you know, this is something else that we do in our session. All right, so let's talk about the meter. What do we know about the meter? Anybody? And this is something that we tell our students every day. When we're talking about length, you know, we're talking about metric units, but our focus here based on the question is in relation to length. What do we know about the meter?
Standard unit for length.
There we go. It is the standard unit. It is what we call a fundamental unit for length. It is the established SI unit for length. Good. So what about centi? Right? So for centi, what do we know about centi? And it's right here on screen. You know, it came up, my mouse moved a little quicker than I intended. Can anybody identify with this fact about the centi? I did hear some persons say that they have used the unit conversion method. The centi,
yes, miss.
Beautiful. It is a prefix, and in the metric system, it denotes a factor of 100th. You know, 100th. But I see Mr. Grant said people usually think of the number 100, right? So remember, I know we started with the meter, which is the base. And then the centi is 100th of, and let us go.
Of a meter.
All right. So how does this prefix indicate the relationship between meter and centimeter? And I know somebody just said it. How does this indicate the relationship? And I just want somebody to just say it again. Just repeat it for somebody who didn't hear.
A meter.
It's 100th of a meter.
It is 100th of a meter. So based on the fact that the centimeter is 100th of a meter, what is the relationship between centimeter and meter? And we're going to say it the other way now, because I know we tell our students all the time, you know, the other way now. What is that relationship?
100 centimeter equals 1 meter.
1 meter.
Thank you so much. We now know, or we are now able to establish this clear relationship that 100 centimeters equal 1 meter. So think about it, teachers. How often do we really look at these prefixes with our students? For them to understand how the name itself influences the value it carries. So it said centimeter is smaller than a meter. It is 1/100th of a meter. And thus the relationship, as we say, we normally preach, 100 centimeter, 1 meter. All right. And one of the things that I know that we don't often do is to write it even in the fractional way, where 1 centimeter is also the same as 100th meter. All right. And this is very important as we look at conversion relationship. So now that we have that relationship and we talk of now we're going to kilo. Kilo. Because we know that a kilometer means make multiplication by 1,000. So now that I put kilo with meter, what are we saying to the students once the students know what kilo means?
1,000 of a meter.
One, let's go again with that one. I'm not sure I heard that one clear. Kilo is multiplication by 1,000. So when I put kilo with meter, my students will now know that
it is 1,000 of a meter.
1,000
is 1,000 of a kilometer.
All right. I'm hearing, I hope I'm hearing 1,000 meters is 1 kilometer, or Miss White has in the chat 1,000 times the meter. Remember the meter as the base, and the kilometer is multiplication by 1,000. So we haven't touched the ruler because in truth and in fact, we know the ruler is a method that we use. But now we're looking at the prefix. Students understanding what the prefix is, and from there, we're able now, the child is now able now to say the correct conversion. I'm seeing Mr. Grant saying 1,000 of a meter. Oh, is what Miss was saying. So Miss 1,000 of a meter or 1,000 meters. All right, so we have to 1,000 of a meter, or of being multiplication there. I hope I get it right, Mr. Grant, and I got it right. So the relationship now, 1,000 meters is equal to 1 kilometer, becomes, we would say, second nature. So the child sees kilometer, they know the relationship that is happening there between the meter and the kilometer unit. The child sees centimeter, they also know that similar relationship. So now, if you are Joseph and your teacher would have taken you through this approach, how is this approach beneficial to you? Anybody? And I know we're at the top of 3 o'clock.
I think it acts as almost like a mnemonic where it prompts their memory.
Okay, thank you, Mrs. Wallace. And I see in the chat, Miss Lindsay also, okay, also giving us that 1 meter is equal to 1,000 of a kilometer. So we're seeing, all right, so that's Mr. Grant.
Right, I was saying, even if Josette doesn't remember the table, by virtue of the prefixes, she could create the table for herself if she don't remember it off the top of her head.
Boy, Mr. Grant, I think you know my presentation, you know. And I see Miss White.
The Spirit of the Lord is working.
I see Mrs. Wilson says it's a pointer reference. It gives, and I see Miss White says it gives relatable meaning to the students. All right. And Mrs. Salmon says she's agreeing fully with Mr. Grant. All right. So we go back to these, to these views that we have. And one of the main things for mathematics is that math is abstract. And because it's abstract, we need to have people access these mathematical ideas to representation of these ideas, right? And also, Collins would have also said that the teaching of representational competence should lie at the center of classroom practice, right? And remember, we're looking at math practice that deals with representation, all right? So we've looked at the unit approach. So just allow me a few more minutes of your time as we're going to now be looking at representational approaches, all right? And these representational approaches, well, I did hear that you would have utilized the ruler before. So let us look at these approaches, and I want you to share your thoughts. So we have that the students were asked to say how many centimeters are in 5 meters. Share your thoughts on these approaches. Do we use these approaches in conversion? I know we use bar models. I know we use tables. Is there anyone in this group who has ever tried the bar model with conversion? All right, I see Miss White is saying she liked the bar model. I wonder if Miss White wants to tell me a little more what she likes about it. What is it that she's seen that she's liking about it? All right, I see Mr. Grant giving me another story there, Mr. Grant.
The bar model is similar to the number line.
Okay.
Yes, and I think it is simple. For me, it is simple and kind of easy to relate because it's just one line going across. And I think for a lot of students that would be easy to kind of read.
Okay. All right. So I see persons liking the bar model. So nobody's liking the table representation. All right. I see Mrs. Robinson saying she likes both methods, and I'm seeing another person too for the bar model. So one of the things when we talk about math and students developing mathematical practices too, we have to remember that students, when we talk about representation, students are open to use of their own representations. But we too, as teachers, have to create opportunities for students to do their representations. So we have to take them through the process. So a child may choose to prefer a bar model when they have been exposed to it. Another child may choose to refer to a table model. But key to representations are that from these representations, our children should start observing a very important thing that is happening, which allows them to make generalization. What is it that we can pick up from these drawings? What is that key thing that we tell them in mathematics that they need to be able to identify? And in order for them to make generalizations.
Patterns.
What are we? Thank you very much. They are supposed to be able to see patterns. So when Mr. Grant telling me that it takes a lot of time, we know when we give them these big numbers, for example, the question that Josette is looking at, she won't be able to write out all of those 5,000 meters. But we know that the children will be able to establish patterns. And once they can identify patterns from the representations, they are then able to move on to making generalizations. All right. And we have a question here. I'm not really going to take you through it because the question is looking at these approaches. Really, how many centimeters are in 12 meters? All right. So do you think that the student would be able to answer this question from the approach we have here? Would this child be able to say how many centimeters are in 12 meters?
Sure, miss.
Good. And remember, we say, because we know our students, mathematical representations, this is where the math connects in the brain. So using that same model now, or those approaches, can we use it now to say, how many meters can I get from 150 centimeters? How many meters can I get from 150 centimeters? And I'm opening here for annotation. Anybody wants to just using one of those approaches, just to write on my screen, just to show me how you could use one of those approaches to say how many meters you could get from 150 centimeters. Any volunteer, any raised hand? Anybody wants? Okay, Mr. Grant. Mr. Grant, the OCD, don't let it kick in now, you know. All right. So I see Mr. Grant would have chosen the bar model. So Mr. Grant is going through. So he has 100 centimeters being equivalent to 1 meter. All right. So I see where he has a part of that 100 centimeters 50, and he has represented that to be half of a meter. And then he now transitions to giving us our answer, which is 1.5 meters. Colleagues, how are we feeling about these approaches? And I know I'm not going to take all the responses, but do we see conversions coming alive? Can we, see how our students will now start, making that association? Thank you so much, Mr. Grant, for just using the bar model. And also, remember, we're saying we could have been using the table as well. All right. And I see Miss Morris going back to our established relationship and utilizing that relationship. All right. So I see Mrs. Wisdom is saying we could use 10 for the slower ones. Yes, Mrs. Wisdom, and that would be our build up. Right? So that's another way. So we could go by now. So we'd have to establish now that 1 unit. So we'd have to be taking it now from, but remember, Miss Wilson, if we're going by 10 now, we have to be careful. All right? Because when we talk about 10 of what is going to make what? So we're going to have to be careful now if we're going to be utilizing 10. Because remember, we're starting with the 1 meter, right? And then we're having that relationship now in terms of centimeters. But the 10 would work perfectly for which relationship? Relationship between which 2 units? Anybody?
Centimeter and millimeter.
Centimeters and millimeter. Thank you so much. So now we have similar question. So we have the centimeter, meter, but can we also use it with the meters and kilometers? Right? And sure we can. We can. All right. So we have used the prefix relationship for conversion, and we've also used the mathematical representation approach, which are the bar model and our table. And really, from here, and Mr. Grant would have said it, and I told him that he was preempting the presentation when he said that from these approaches, we now see, or he would have expressed that our students can now develop for themselves their own conversion tables. And they understand where it's coming from because they were able to make it for themselves. Good. And from here, would have already spoken about patterns. Being able to identify patterns allows them to make generalizations. And as they make their generalizations, we're saying, how can they now use it to say when they are moving from smaller to larger or larger to smaller units? What generalizations, how can they use it now when they think about these? Moving from smaller to larger. And I would have, just simply underline, we have 100 here centimeters, we're moving to 1. And we've already established that the centimeter is a smaller unit and we are moving to a larger unit. What do they notice? What is happening with the number? So remember, as we interact with students at this level, We have to be asking them the questions. We have to be, what are you seeing? Why do you think it looks that way? And I see smaller to larger, number gets smaller, which division usually makes numbers smaller. So you see the questioning coming up that Dr. White was talking about. So you get a response like that, which is the first line, smaller to larger, number gets smaller. What mathematical operations would make numbers smaller? And then you start pulling from the students and you start eliciting their thinking in the lesson, and you're using their responses in the lesson, and they're developing their own mathematical reasoning skills. They're also developing the conceptual understanding. So all of this process,
Madam Thousand.
Yes, ma'am.
Sorry to interject, but even with the prefixes that you just showed,
yes,
where you said that for centi it is 1/100th of a meter. Well, probably I'm expecting, but the students should realize that 1/100th means 1 divided by 100. So if you're converting from a small to a large, notice that they're going to be dividing, because 1/100th means 1 divided by 100. So the prefixes to me should help as well.
And based on the positioning of these objectives in the curriculum, those are some things that the students would have been exposed to already, the fractions and the earlier part of decimals, because it's at grade 9. So thank you so much for that. So you see the generalizations are coming out by those approaches that you would have done. And we can move away now from the telling, and the running with that. So we would have picked up that we're going larger to smaller. The number is growing. So therefore, multiplication is selected, is a desired operation, and would have identified division as a desired operation now when we're going from smaller to larger. So Joseph now, having experienced these approaches, she's now in a better situation for her to apply. And I know earlier out, I had you colleagues sharing with me these responses in the chat, where she's converting the kilometers to meters, so she gets 5,000. From there, she then continues now to do her division, and by so doing, she knows she will need 2,500 cones. So our math practice, what are we looking at here? Math practice 3, use and connect mathematical representations. And we have Marshall and colleagues suggest 3 strategies. 1, encourage purposeful selection of representations. So we encourage the students to choose representations which are purposeful, which will lead them to the answer. So if we're dealing with meter and centimeter, we're not going to tell them to represent millimeter at that point. Let us just keep them focused. Yes, those will be explored at some point, but let us be targeted in our discussion and where we're leading our representations. Engage in dialogue. And right throughout this afternoon's presentation, all presenters would have been building on that, the dialogue that we have with our students, right? And the dialogue we're having with these representations are for them to see the connections that exist. And what do? Alternate the direction of the connections, right? So we use the connection to go from smaller to larger. We also use it to go from larger to smaller. So we are alternating the connections that they're making. They're utilizing the same representations, but they're doing conversions from larger to smaller and also smaller to larger. Any thoughts, colleagues? What are your thoughts? How do you feel about using mathematical representations when we are going through concepts of conversion of length? How do we feel? Anybody can just share. How do we feel about this part of the presentation? Anybody in the chat? Anybody wants to unmute?
Nothing as yet, Ms. Townsend.
I feel really appreciative of this part because I've never seen it in this light before, and it has really opened my eyes today.
Okay. All right. I'm very happy for that, Mrs. Robinson. Thank you for that. All right. And as
Mrs. Thousand.
Yes, ma'am.
I'm sorry that this wasn't extended to other pathways as well, because I think it would be beneficial.
Okay, but you know, I'm happy that you are here, because you know, when you go back to your department meetings, these are some of the things we want you to take back to your colleagues. You know, when you're having those conversations, you say, colleagues, have you ever thought about using this when you're doing conversion and metric units? Have the discussions with them. You know, we learn things and we share. That is the community we want to have in Region 5 and in our schools. All right, so I encourage you to share this with them. Of course, we will be sharing the link to the recording, so you can also share it with them. And we will take into consideration as well the content of what we share and how it extends throughout the region as well to the other teachers. So colleagues, you know, we've had this session, we're talking about engaging our students. We're talking about exploring the practices to support conceptual development. And we have looked at, you know, these 5 aspects from our mathematical teaching practices, our effective mathematics teaching practices. And we've also looked at online resources that we can use to support this development. So we have our 8 practices, all right? So I know we're looking at the diagram and some persons quickly count and say this is 7. But one of the key to our practices is that establishing the mathematics goals to focus learning. So though we did not explicitly mention that, but we went through our session, did you as participants know what your session was going to be about? Anybody? Were you able to say, if someone called and say, you know, what is happening? Where are you in the session? Were you able to say where you are in the session? At what point you were?
Yes, miss.
Great. All right. Were you able to say, are you able to say that you contributed? You made a contribution in terms of what the discussions were and where the direction in which the topic itself or the focus itself was going. Right. And you know, and I'm seeing the yeses in the responses, because when we go into our classroom and we talk about establishing the goals, the mathematical goals to focus learning, we want persons to understand that what we're looking at, we're able to see right throughout a lesson. The student is able to see the relationship about the different discussions that happen, the different concepts that are explored, and how it comes all together for them to achieve the objectives laid out for learning on that day. Would have been able to look at the task, implementing tasks to promote problem solving. We did not touch, you know, so much on procedural fluency from conceptual understanding, but we know that's a big one in itself. We'll have to look at another time. But we also looked at the mathematical discourse, and look at how that wraps up these 4. The questioning, the connection of the mathematical representation, getting the students' responses and using it and supporting the productive struggle. So all mathematical practices goes into making a class that is very mathematical, that is conceptual in nature, and it will help students to have better understanding of math in itself. All right. So I do thank you, colleagues. At this time, I'm going to take any questions that you may have. The QR code on the screen, it can be scanned using your QR code scanner on your mobile device. Okay, the form, the link to the evaluation form will be shared in the chat as well. But if you have any questions at this time, you can go ahead. Any questions at this time? Okay, so the evaluation form has been shared in the chat. So colleagues, I just want to thank you for participating in the session. You know, we're looking at how we keep our students engaged. We know it's challenging. We know it's not so easy even at this time, but we want to help them to overcome their challenges, and we want them to be able to master math concepts. All right. All right, go ahead.
Just to remind all participants to ensure that they have signed the register, because that's very important.
Okay, thank you for that, Dr. White. And I see where Miss White says, not a question, but comment. I like the way this was done. I'm happy we were able to please you in relation to the presentation, Miss White. And I do thank you, participants, for your high energy participation, for the comments in the chat, for the moments of you unmuting and also sharing. And I do, as we've always said, we are here as a mathematics team. You can reach out to us, reach out to your coaches, reach out to the team in general. We're here to support you. You're planning your lessons, you're having challenges, you need a little support. That is why we're here. So we do look forward to hearing from you. That's a comment there?
No, the link that was shared is the register again. It's not the evaluation.
It's a register again that was shared just now?
Just
All
now.
right,
In the
sorry about that. All right, let's see if we can get that corrected, because it really shouldn't be. All right. All right, so just let us see that. Mr. Johnson?
Yes, I'm working on it. Let me just put it in the chat.
Okay.
All right, it's in the chat now.
Okay, thank you. Thank you so much for that. I think that's looking like the same one, Mr. Johnson. All right, so there I've shared. Okay, so I've shared a new one. Thank you so much, Ms. Jackson. All right, so I've just shared, let me just share again. So I've shared it twice now in the chat. All right, I do apologize for that. So thank you so much for participating. Do have for yourself a great afternoon. All right, colleagues, thank you so much.
Thank you too, Ms. Townsend.
Okay, you're welcome. Miss Lisa, Mrs. Letts, I'm just checking if you had written in the register, so that we will have that, we'll have your email to share the recording with you. So just checking.
Yes.
All right then. So as long as you are in the attendance register, it will be shared with you. Okay.
Thank you. Thank you.
You're welcome.
Careful. Aw, now my phone is wet. Maybe if I blow on it. I don't want to break my phone.
Okay, so just ensure that you have the link. You're welcome, Mrs. Wallace. You have the link to the evaluation form.
I'll put the empty glass in the pool.
Before you go.
I have an underwater camera and my phone doesn't get wet. These look so good.
I've just reshared the link to the evaluation form, just in case you did not get it as yet.
Just want to thank Mrs. Plummer for attending our session as well, education officer, and any other officers, senior personnel that I haven't mentioned. Thank you for coming to our session.
Thank you. Thank you for thanking me, Mr. Johnson.
You're most welcome.
Okay, I will be ending the meet now. So let me hope that we all have accessed the evaluation form and that we also would have accessed the attendance register.